In topic 4.4, we're going to be talking about the Earth's atmosphere. We'll be discussing the composition of the atmosphere, wind patterns, the Coriolis effect, convection cells, and those sorts of topics and how they impact the Earth. So the atmosphere is the layer of gases that surrounds the Earth, and the composition of the atmosphere is mostly nitrogen and oxygen. Together, those make up about 99% of the Earth's atmosphere. The majority of that is actually nitrogen, 78% or so. And then if we take what remains, we can see the other components of the atmosphere, argon and hydrogen and so forth. One thing that you might notice is that carbon dioxide is actually a really small proportion of the Earth's atmosphere, but obviously it has a very significant effect on the Earth's climate. But the actual amount of carbon dioxide in the atmosphere is relatively low. When we think about the atmosphere, often we break it up into different layers, and they are given names, then they have various characteristics, and different phenomena take place within these layers of the atmosphere. We could see them here. The layer that we experience most directly, the layer of the atmosphere that's closest to the Earth, is the troposphere. Okay? And that goes for about 18 kilometers above the Earth's surface. The troposphere is where we live. It's where planes fly. It's where mountains are. It's the parts of the atmosphere that we directly experience. As we move up into the next highest level is the stratosphere. Stratosphere is where we find the ozone layer. That's an important factor that is we'll be talking about in our course. Above that is the mesosphere, the thermosphere. This is where the aurora borealis, the northern lights, originates, if you've seen that recently. And then the outermost layer is the exosphere. And then some satellites orbit the Earth in the exosphere. And then once we're beyond the exosphere, we are in space. And gravity affects the gases in the atmosphere just like it affects all the other parts of the Earth. And when we think about how these layers of the atmosphere are arranged, there are important characteristics of density and pressure. And so lower in the atmosphere, we have higher density of gases, and we have greater air pressure, because we have all of these gases that are above the troposphere sort of pushing down, increasing the pressure at the lower levels. Sort of as if you imagine if you go swim deep into a pool, you could feel the pressure of all the water above you. Well, the same sort of factor happens in the atmosphere. And we also see this line here on this graph represents the temperature. As we move up through the atmosphere, what we notice is it sort of changes. In the troposphere, as we go higher into the atmosphere, temperature decreases. And we often are familiar with this because, for example, if you climb a tall mountain, if you vacation at a high elevation, you know that it's generally cooler. As we go up into the atmosphere and the troposphere, it gets cooler as altitude increases. And in this troposphere, this is where we experience weather. Okay? Mixing of gases in the troposphere can result in various weather patterns, and the circulation of those gases are really important. As we move up into the next layer, the stratosphere, the boundary between layers are called pauses. The tropopause is between the troposphere and the stratosphere, then the stratopause, the mesopause, etc. As we get into the stratosphere, now as we continue higher into the atmosphere, the temperature actually gets warmer. And that's due to the greater absorption of ultraviolet radiation. Less ultraviolet radiation is being filtered out. And this is where the ozone layer is found, the ozone layer which protects from ultraviolet radiation. So we move into the mesosphere. Again, now we see temperature dropping as we get higher into the mesosphere. And then in the thermosphere, we can see here these the temperature increases again. So those are the patterns of temperature. I wouldn't focus a lot